I was thinking you were explaining flannel and weave beforehand, so but I'm trying not to go into deep because it's very thin ice. Yeah. So my name is Timo, and I just want to give you an overview from a developer point of view. I'm not a network engineer. I've never been, so bear with me. Laugh with me, not about me. You know, networking is a huge topic, and we don't have that much time. So I think I go straight to the solution. And so the answer to container networking is there's no one size fits all. At least currently, I don't think that there's just one solution. And there's this very famous German animal. At least a lot of people are looking for it. It's rarely seen. To give you a little background, containers enable microservices. We hear that a lot. Whoa. Thank you.
I tighten it before it goes again.
That should be okay, though.
There's a knob on it to have.
Don't break it. It's plastic. What does it mean? It enables us to do to have small teams, 2 pizza teams, to have loosely coupled services and to deploy independently, right? So you can even throw away your services because they are so small, and you just write a new service that replaces the old one. And but it's not free lunch, and we're actually trying to get the complexity out of the services, but instead the complexity is not gone. It's moved to the network, right? So network is becoming software, and I'm a developer, so I think, okay, this is something I'm going to use more, because it's just software, and I can just start it on my computer within a container. I run weave of flannel or other Calico, for instance, and it's just easy for me to do that because it's not hardware anymore, and I don't have to buy that, and I don't usually I'm not in a data center, right? So let's find the hammer. And that's what I'm trying to do. I did some research in the last couple of months, and I just want to share some of it with you. And so that's game over for me. I'm a noob, and I'm trying to explain some of the concepts. So there's socket plane. You all heard about it. It was bought by Docker, and it's an early alpha prototype, but if you look at the GitHub repositories, there's not much activity right now. At least it's not visible for us. What's happening, probably something integrating with Docker. And so I know least about that socket plane tool. It's based on Open vSwitch, and it uses console and the consensus of console to have the information about where the containers live. So the control plane is within console, and it then routes your traffic between your containers. And as far as I saw, it's currently not possible to run that on AWS, for instance, because it needs multicast. So, done with it. Weave. We have some Chorus clusters running with Weave because some customers wanted to have some features of Weave, and that's why I can explain a little bit more about Weave. And we've been to the Weave offices, and I've met Finton a month ago in London. So I have at least a little bit more knowledge about Weave. So what Weave does, it's a virtual Ethernet switch. That means you have an L2 network across your containers. That is where all the Ethernet frames are encapsulated within UDP packets and sent by the Weave router from one host to the other. And how many of you are networking engineers? Okay, there are some. How many are developers? Okay. So the networking engineers probably know that L2 is usually not scalable, and I think that's a huge problem when you hear something like that. And I think that's still true with Weave, but at least they have some smart logic in their router to avoid that ARP explosions and broadcasting to every peer of the Weave network. At least it must be a little bit more scalable. But what's very interesting about that is that it doesn't use consensus underneath. It just uses the routers that automatically learn where the MAC addresses are, and then sends the UDP packets over to that peer where the container actually lives. And there it's unpacked and given to the containers. And they optimize that, but it's still in user space, and it's probably not that fast. It's written in Go. They even have encryption, so it can go from one data center to the other data center. You can have an L2 network between data centers, which is very interesting, and things like multicast work over that network. So if you're, for instance, on Amazon, there is no multicast. But if you use software, something like Vertex, that uses Hazelcast, by default, it uses multicast to actually do service discovery of your microservices, which is kind of nice because it's transparent and it just works out of the box. And it doesn't work on Amazon, and there's an AWS provider for it that helps you doing this. But you can do that even across your data center with Weave. And also, if you set up something like Elasticsearch or Crate.io, those are also using multicast for service discovery, and that's why it's kind of interesting to add a network on top that provides that feature for you. So you can have you can just easily set up services that auto-discover themselves, and you don't need any other service discovery for it. Just a real network. Yes. And what I already said, so the limits are probably clear that it's not the most scalable solution. Currently, they're for all the tools, they are very young and fast-moving targets. So probably what I say now is obsolete in a couple of weeks. But I think by design you can say that something isn't the most scalable solution. But if your use case is you want to just run maybe 50 containers or 100 containers, then it's maybe your solution, because you have other things you want to run and you want to have by such a solution, right? Because when you have a layer 2 network, then you can actually use all the tools that you're already familiar with, and it all works. Flannel. So you're probably better explaining that. But I think Flannel is from Chorus. So Chorus uses Kubernetes lately a lot, and they announced Tectonic, and that's what Flannel was designed for, to assign a subnet per host with IP addresses you can give to containers, which is similar to what Kubernetes needs. And you could do that on Google Compute Engine, but not on other cloud providers. And that's what Flannel is for. And you can get rid of Docker port mappings by that, and containers can talk to each other directly. And it uses etcd as a control plane. Compared to Weave, where Weave didn't have a consensus algorithm. And etcd is based on the consensus. So etcd is, you really have to take care that etcd is available. Because if you take the CAP theorem, etcd is mostly on the consistency part and the network partition tolerance, and not on the availability part. You have availability by another node taking over the leadership, but if the majority of the cluster fails, or you have some nodes that are in a network split, they are unavailable and they do not work. And we, for instance, does work. It even works in a topology where some nodes cannot reach all the other nodes, but just part of them. And Weave notices that and routes the traffic through the nodes that can talk to the other nodes, right? And but on the other hand, Flannel is very flexible in terms of what underlying network you have and what you want to actually how you want to get the packets from one host to the other. So you can use, similar to what Weave does, UDP encapsulation. Then Flannel is obviously data plane and control plane, but you can also use something like VXLAN or even just a host gateway, or just allocating the IP address and just giving it all to your network infrastructure. So then Flannel is just for the control plane and not for the data plane. And the last one, Project Calico, they have a completely different approach. They do not use any encapsulation, but they use BGP, and they push routes on your host. So it works like the internet does. So let me explain to you, are you familiar with how a network interface is injected in the Docker, like in a network namespace with Docker? So you have pairs of virtual Ethernet interfaces. One is inside the network namespace of Docker, and one is outside. And usually you have that one outside bound to a bridge, the Docker bridge, and then your network is netted to the containers. So what you do is the mapping. You map a port, like let's say port 80 of your container. You map that to a port on the host, and then you can talk to the port on the host, and the traffic goes through the bridge to the container. With Project Calico, actually there's no bridge. The vast interface is just there, and they push routes on the host to actually route the traffic to another host, to another container. And that brings you to raw network performance because you don't have any encapsulation. It's not necessary. And they also have ACLs. They have profiles, so you can put containers into profiles and then you can define rules. You can say, okay, other containers with this tag can talk to the port 80 of this container. Or you can say, okay, outbound, it's just allowed to go through that subnet. So the model is very interesting. It looks very nice, and it also uses etcd as a backend right now. And for me, at least, it looks like a really nice integration into existing orchestration frameworks. Thanks for listening. Questions? You see, I was really, I was hoping you were explaining.
I think you did a good job of giving a good overview on the 3 popular options for Docker networking.
Thank you. So, get me on more than ice and just ask me some questions, and I hope I just give you, the dangerous half knowledge I have. Yeah.
Yeah, imagine you're running your service behind network header translation. So not only the Docker layer, but really some physical router that is not. Are some of these tools suitable for that? Because I didn't find anyone. To have one node behind node and one with a public IP address, and then set up the networking.
I would say you need some APIs on your router then, and your orchestration framework should, tell the router where the stuff is, right?
Yeah, sure, but if that is not in your control,
Yeah, it normally works just fine if you think about it. A lot of people are running these tools in like EC2 or Amazon's cloud, and they're definitely doing natting at the top layer that you're not in control of.
Yes.
So your gateway should handle that for you. So you're definitely going to be double natting in those cases.
Yeah.
But it works, but no one likes double natting, but you end up just having to do that. So it usually works.
Yeah, we run a couple of HA proxies behind the EAB, for instance. That they talk to etcd and they know where the containers live. So yes, you need some software load balancer as well, and you do double netting.
Yeah, so your question is like the container is going to come out and it's being natted out to the network, right? So the packet now has a source of the host that it came from.
yes.
Right? So now the local IP tables.
This is the Docker layer.
Yeah, we're talking about the Docker layer. So most of these tools plug into the Docker bridge, which takes advantage of the Docker masquerade role into IP tables. So the packet leaves the container, traverses the Docker bridge, hits the IP table role, nats the IP from the host.
Sure, I get it. This works. This is fine.
Right, so now you're going to go and traverse to the next layer of NAT, which is going to do the same thing for that IP coming back. As you make your way back, the first layer is going to have to, unwrap the packet and say, well, go to that host. That host is going to unwrap the packet and look in the state table to know that it needs to hit the Docker bridge, which will then route back to the container.
Okay.
So nothing really changes here as far as networking goes. It's just the default Docker model has you in this situation where the best way to plug into Docker, since it doesn't have the network plugin model, is to just put yourself in between the bridge in order to basically configure Docker with the IP range you want it to hand out to containers.
Okay. IP set doesn't work overnight, right? Unless you modify the nothing route.
Yeah, so like you got to pick your networking model based on the network that you have.
Sure.
So if you don't want to use, double NAT's going to trip you up, then you may want to look at some of these other solutions. Like you can use things like just a raw interface with Docker if you want. If you have enough interfaces on the machine, you can actually bring it into the namespace. You can use a Mac VLAN, IP VLANs work. So you're not stuck with the double natting if you don't want to. And I'll actually be showing that in my demo of how you can actually use different networking implementations, even with Docker. So a lot of stuff we're talking about now is for ease of use. If you don't want to change everything and you want it to be fully automated, you start with the Docker bridge and you kind of inject yourself there.
Yeah, but you can always just create your network namespace beforehand, configure it like you want. You need an orchestrator to do that, or have something like pods where you have multiple containers, and then you maybe just first run a container that creates the namespace and configures the namespace, and then injects the interface or whatever you like. You can do a lot of things, and you can automate those things.
The nasty thing is if you're using, for example, a consumer router that you are behind, right? Then you're not in control of this router. Some tools I tried were not able to do this because it assumes that the connection is initiated, the UDP session is initiated from behind the router, not the outside. So this is the thing I'm running into, but maybe it's not interesting to everybody. So
Well, yeah, I actually have written like tools called like the Flannel Route Manager that integrates with anything that has a programmable API. So we know Flannel has this route table stored into etcd, so I know what the next hop is for each range.
okay.
Now in GCE, what I do if I just want to use, if I want to bypass the overlay network and I just want each host just to have the subnet, I have to tell the upstream gateway or router where the next hop is. Right? So there's a little Go binary that we use that will just traverse the entire state table or route table for Flannel. I know where all the next hops are. And I just tell the upstream router. So in GCE or AWS, I could just make an API call and say, add this route, this static route, anything going to this /24 goes to this particular host. And then just normal networking takes over. So right, if you have a consumer router, we need a way to poke and prod that thing if we want to be able to use this overlay network. But you can also configure Flannel to use a portion of the subnet. So if you give your whole network a /8, right? I can tell Flannel to deal with a /16, which puts me on the same L2 as the nodes themselves. So you don't have to be forced into a whole separate subnet range, right? You have a lot of flexibility there. So if you want to do that, you can do that even with Weave. You can give yourself a portion of a larger network and not have to deal with any of this.
Okay, so that's Flannel you're talking about now.
All of them work this way, and I'll actually be showing this in the demo where when you configure things, just pick the subnet that you want. For ease of use again, most people just say, hey, use this 10 dives, and then handle the routes yourself.
Okay, cool. Thanks.
You can even run more than one network if you like. Like you can probably even run Weave inside a Flannel or Weave inside Weave. I actually wanted to try it out. Yeah, it just works. And
At some point it won't work, but yeah.
no, it doesn't make sense, but yeah. So my whole point is actually it really depends. It depends on your use case, and it depends on your existing infrastructure, and you have to look into those tools and dig deeper. And just wanted to give you the overview. Any other question?
Yeah, you were talking about Weave and how it all worked, but I couldn't really get from your story what a Weave routing process or a Weave router. How should I see it?
So Fintan will be right after me and talking about Weave. So, but you can just Weave runs inside a Docker container,
Yeah.
and then you have a small command, or you can use something like PowerStrip. I don't know if you heard about it. It's just a proxy in front of Docker, which lets you do pre and post hooks to configure things. So you run a Weave command, and then the Weave command launches the Docker container and configures the Docker container so that you have the Weave interface inside of the container. But you also can do that manually. You can, for instance, with the default setup, Weave has two interfaces: the Docker interface and the Weave interface within the container. And sometimes you have software that looks for the default interface and finds the Docker interface and just finds the wrong IP address and something like that, and you do something like zero configuration. Then it works on the developer laptop, but it doesn't work in production. So you can also do your own setup where you just create a namespace without the Docker interface and then injecting the Weave interface and something like that. So yeah, that's also possible. Cool. Thank you.
No more?